2.1, the conclusion B. So this will be our last problem we're looking at, but I wanted to talk about a couple things. If I have something like this, 5 plus 1 over x, and as x approaches infinity, this all goes to 0, so we have 5 plus 0, which equals just 5. Okay, we get that. All right. If I have 5 plus infinity, isn't that just going to be infinity? If we keep adding to infinity, it's still going to be infinity, right? Same thing if I have infinity minus 5, I'm still going to get infinity, right? Because infinity is way out there. Now, we're not going to write it this way, but just in concept alone, we get it. You know, infinity it's not going to make it any smaller by taking away 5 or adding 5, right? Smaller or bigger. Okay, so let's look at a problem that we say, I don't think I'm going to want to graph this problem. So let's look at 1 over x minus 1 to the 4th power plus 5. And we're going, no, I don't think I'm going to graph that. Let's see if we can do the limit without graphing it. So we have the limit of f of x. We're going to look at different situations. Let's say x approaches infinity. If x approaches infinity, that means this denominator is going to get bigger and bigger because we're going to fourth it, right? Gets bigger and bigger and bigger, so this all goes to 0 plus 5, so that's just going to equal 5. Okay, but now let's look at this. X cannot equal 1, right? So we're going to look at to the left of 1 and to the right of 1 to see what's going on with the graph. So we're going to look at the limit of f of x as x approaches 1 from the right, and the limit of f of x as x approaches 1 from the left. Okay? Now to do that, I'm just going to look at this portion and ignore this, because remember, whatever we do here, adding to the 5, is just going to be kind of just a little bit of a change. So I'm going to look at approaching 1 from the left and 1 from the right. And then we're going to see what happens with this, just this part. Okay, and then go from there. Okay, so choosing 1 from the left, how about negative 1? If we put a negative 1 in there, we're going to get a negative, I'm going to just go ahead and write it. We'll get a negative 2 to the 4th power. All right, which is 1/16. Let's look at to the left of 1, zeros to the left of 1. If we put a 0 in there, we're just going to get a 1. So already we went from 1/16 to 1. So we're growing. Let's see what happens if we put a half in there. We're getting closer and closer to 1. If we put a half into this, 1 over 1/2 minus 1 to the 4th power. What this ends up being, I'm going to kind of write it down here. This is negative 1/2, right? Negative 1/2 to the 4th power is just going to equal 2 to the 4th because of this power of 4. The negative is going to go away because of the fraction of the denominator. It comes up to just 2. So now we're at 16. So we went from 1/16 to 1 to 16. So what is this telling us? This tells us that this is going to infinity. Okay, so we can say from the left is going to infinity. Let's see what's happening from the right. Let's choose something from the right of 1. How about if we just put 3 in there? If we put a 3 in here, we get 1 over, 3 minus 1 is 2, right? So we have 2 to the 4th, which is again 1/16. Okay, let's put a 2 in there. If we put a 2 in there, we're just going to get 1. So we went from 1/16 to 1. Okay, we're going from the right. So let's get to the right of 1. Let's do 1 and 1/2, which would be 3/2. I'm just say 1.5. If we put a 1.5 in there, 1.5 minus 1 is just a half to the 4th, which gives us 1 over 1/16, which gives us 16. Okay, so we went from 1/16 to 1 to 16 again. So what's going on? Are we going to infinity again? Yes, we are. So in this situation, we know that the limit of f of x as x approaches 1 is going to be infinity. Now this may not be true for all problems that are like this. You actually have to go through and test them, see what happens. Now what would this look like graphically? We're not going to draw the whole graph, but if we were just to go like this, where this equals 1 right here, this asymptote here, we would have something looking like this. From the left of 1 it's going to infinity, and to the right of 1 it's going to infinity.